Hello everyone, welcome back. This is 2-10, Entity Usage and Basic Entity Circuits in the Combat Redstone series. I'm Immovable, and today I will be talking about some basic entities, how you would use them, and the specific properties of them, and how they would react to certain components or to certain entities. And then we'll also talk about two specific topics, including floats and hopper clipping. And then I'll also talk other things, such as some entity placement techniques, some special block properties that you should remember, and of course some basic entity usage, circuits, and then also giving you some useful resources, because quite frankly, other people who have made some documents about some entity data that you should be aware of when you're doing entity circuits. And finally, I will just get on to the exercise. So without further ado, let's get started. So let's get started by introducing all of the entities that I'll be introducing. I will not really introduce too much about mobs in this video, because that would take a long time. Again, this video I already recorded it once, so yeah, it already takes quite long. So I think a 2-hour video would be enough for everyone. So yeah, anyways, so minecarts, that's the first part. There are 5 types of minecarts. So they are in respectively minecart, minecart with chest, minecart with furnace, minecart with TNT, and minecart with hopper. Now, there are 2 container minecarts, respectively the minecart with chest and minecart with hopper. Also, throughout the video, I'll just say these 4 minecarts respectively: chest minecart, furnace minecart, TNT minecart, hopper minecart. I sometimes will reverse the order as well. So yeah, just be aware. So let's just introduce some basic properties about minecarts. So a minecart is 0.7 blocks tall and 0.98 blocks long or wide. Minecart is a square entity, basically. Well, a lot of entities are square entities, so we don't have to really worry about them too much. So yeah, it's basically 0.98 blocks long or wide in both directions, horizontal directions. So yeah, and a hopper minecart can take items from a chest or hopper minecart above, so basically the container minecarts. So yeah, that's basically a special thing about hopper minecarts. So okay, we have introduced the minecarts. Now we will introduce the 2 remaining ones that are also quite useful. Armor stand. An armor stand is 1.975 blocks tall and 0.5 blocks long or wide. And a boat is 0.5625 blocks tall and 1.375 blocks long or wide. For these 2, I think just remembering the height of the entities are good enough. But for minecarts, it might be a bit more specific. You should probably remember both of the values. So yeah, now I will go on to introducing the very technical details about how minecarts interact with other minecarts and some containers. Right, so let's get started. So the first thing we want to investigate is the interaction between a container minecart and a hopper minecart. So we want to know what exact range of values can a hopper minecart take items from another container minecart. So I'll just use a chest minecart as the other container minecart here. Alright, so let's just investigate in its height first. Alright, so let's find the lower bound and find the upper bound. Okay, so here we have a bunch of command blocks that we'll just test it. So you'll see there are some test values. So this is the command. I'll just show you in full. So /summon chest minecart, the 3 coordinates, and then we have this NBT tag, no gravity 1. This is to float the minecart in air. because we don't want the gravity to affect our minecarts. So, okay. So what would be the lower bound? So let's just say we would place it at this y coordinates here, 66.3. So if we summon it, we can see that this chest minecart is not able to send items to the hopper minecart. But then if we make the value just a bit upwards for the y coordinates, so 66.301, you can see the item can actually be received by the hopper minecart. Don't worry about this thing yet. Yeah, the hopper minecart can receive items from the chest minecart. I probably should introduce it here because I think I will probably forget it. But basically how you would do is that you would have the hopper minecart pushed into the chest minecart with a piston. So essentially like this. So in this way you can actually have the hopper minecart receiving items from the chest minecart. So yeah, anyways. So we find out that the lower bound has to be greater than 0.3 blocks, since this hopper minecart is exactly on the block and this is 0.3 blocks above. But then 0.3 cannot work, but then if we add just a small value to the y coordinates, then it would work. So basically above 0.3 for the difference in height. So let's take a look at the upper bound. So here we have 68 first. Yeah. So would this be able to deliver? The answer is no. 68 is actually a bit too high. But then if we set it at a just a lower value, 67.999, then actually if we place an item here, it can be received by the hopper minecarts. So we find out that the maximum difference is strictly lower than 2. So yeah. So for the height difference, we would see that the lower and upper bound are 0.3 and 2, not inclusive, both. So yeah, that's the height difference. So now we talk about the length difference. So how horizontally it should be. So this time this hopper minecart is not pushed into this block here. It is actually in at the center. So you can verify it by using this command. We will use this command quite a lot. So yeah, get used to it. So it's data get entity, the UUID of the entity, and then POS. POS stands for position. Remember to capitalize the P. So we see this is exactly at the center of the block. So yeah, all right. So what values of this minecart, or what the coordinates should this minecart be? In the Z coordinates, it will be Z coordinates in this case, such that the hopper minecart can receive items. So let's check for 24.509 here. It actually cannot receive the item, but then if we have 24.51, if we spawn it in, then it can actually be well received by the hopper minecarts. Now 24.51 seems like a very unreasonable number, but it actually makes quite a lot of sense. Now remember that when we say minecart is 0.98 blocks long, this means that it has 0.01 blocks in gap. 0.01 block gap. So it's very hard to see. I'll just open this F3B. This is so. Let's just be funny and use a spyglass. So you can see there's a tiny gap between here and here in terms of its length, and this is 1 centimeter. Literally 1 centimeter here, or I should say 0.01 block. No one says 0.01 is at 1 centimeter, but yeah, anyways. So that is a 0.01 block gap. And this exactly makes sense because we need a 0.01 nudge towards the Z axis here, such that this hopper minecart can receive items from this chest minecart here. So yeah, that actually makes quite a lot of sense. And it should be quite trivial that on the other side, if you have 26.491, So that is 0.991 blocks apart. So that cannot be received. But then if we make this value slightly lower, then when we summon it, then it can actually be received. So yeah, we basically have concluded that for the horizontal difference, it has to be strictly between, it has to be less than or equal to 0.99 blocks. Because this here, we already say is 25.5, and then minus 24.51, so that's 0.99. And if we have 26.49 minus 25.5, we also get 0.99. And 0.99 is the exact value where it can still work. So yeah. So including 0.99 in this case. So we have investigated the important relationship or the criteria for a hopper minecart to receive items from another container minecart. So yeah, that is basically for this case. Now we would go on to see another case where we replace the hopper minecart with literally a hopper. So in what coordinates can the hopper receive items from a container minecart? So let's check. Again, we check the y values first. We check the lower and upper bound. So 66.3, this chest minecart cannot put items into this hopper. But then if we make the value slightly higher for the y coordinates, so here, now it can actually be received. So yeah, it should be strictly higher than 0.3. And for the upper bound, so again we have 68. But then this cannot receive. But if we have 67.999, then when we place an item here, it can actually be received. So we again conclude that the height difference is basically the same as to this case. So yeah, no difference for the height. So what about the horizontal difference? So here again we would check for the Z values. So this is 24.509, but then you can see this hopper cannot receive any items from here. Then if we change the Z value to 24.51, then it can actually receive this. So let's check for the other side to see if it's the same. So we have 26.491 and it cannot be received. But then if we have 26.49 as an example, then it can actually be well received. And this is exactly the same as to why there is like a 0.01 difference because of the minecart's length. And yeah, you can see this Z values are the same as these Z values. So yeah, they basically have no difference at all. No difference. Also, just saying that in the documents, which I will have the link in the description below, I will consider this hopper, and later we will see a barrel here. If we have a full block, then I will calculate the coordinates of the block, not as the right hand side you see the targeted block -4, 66, 24. We will calculate it as the x coordinate we would plus 0.5. Z coordinate will also plus 0.5, but we do not change the y coordinates. So it would be calculated as -3.5, 66, 24.5. This is to reconcile with the position of the minecarts if it's at the center of the block. So yeah, it makes the calculation a bit easier and easier for you to reconcile this case with this case as an example. So yeah, now I have talked about this case. Now what if we think of a hopper delivering items to a container minecart? What will happen? Let's take a look at the height case. So again, we will have this 66.3, and we see it cannot be received by this minecart here. But then if we have 66.301, then it can actually be received by this minecart. So the lower bound is again higher than 0.3. Or in this case, it's actually negative 0.7, because in respect to this block is negative 0.7. Okay. I hope you know why this is the case, because 0.3 minus 1, negative 0.7. So for this case, it's actually very similar. So we have 68 again, but then it cannot be received. But then if we change the y coordinates to 67.999, then this hopper can deliver items to the chest minecarts. So for the height bound, we find out that it is negative 0.7 to 1 and not inclusive for both values. So yeah, that's the height difference. What about the horizontal difference then? So we take a look at this case. So there are quite a lot of values to check for this one, because the minecart can be also inside this hopper. That's the hopper cannot put items in. So we take a look at the furthest case first. So let's have 24.509, so a bit further here. So if we place items into this hopper, it cannot be received by the minecarts. But then if we have 24.51 as an example, then it can actually place items into the minecarts. So again, we will see the difference is 25.5 minus 24.51, which is 0.99, 0.99 inclusive. Okay. But then, if we take a look at the closest distance, so let's take a look at 491, 26.491 this is. So, which is actually quite far inside here. So we place an item here, it cannot deliver to this minecart. However, if we do 26.49, which is slightly into this direction now, then we can see that it can actually deliver items to this minecart. Very nice. So the difference would be 0.01 to 0.99 and 0.01 to 0.99 inclusive. Okay. So yeah, that's basically it. We can also check in this direction, although I'm not going to waste your time here. So you can just check it yourself. You will derive the same conclusion actually. So yeah, we checked both of the values, the height and the horizontal difference. And now we would move on to investigate another one. What if we reverse these two things? What if it is a container getting items sucked by a hopper minecart? What will happen? Let's take a look at the height difference first. Let's look at the lower bound. So the lower bound, if we have 66.499, then if we place items in this barrel, this hopper minecart cannot receive it. However, if we have 66.5, then we can actually have this received. So this barrel is 68 in y coordinates, so 68 minus 66.5, that will be 1.5 blocks. And we should say it's negative 1.5, because in respective to 68, it's negative 1.5. And then what will be the upper bound? So we have 67.5 to test. So, which is actually a bit inside the barrel, but then you can see the barrel cannot deliver items to the hopper minecarts. But then if we have 67.499, what will happen then? Then this barrel can have the items being sucked by a hopper. So what do we conclude here? Basically, the height difference has to be between negative 1.5 and negative 0.5, and only negative 1.5 inclusive. Yeah. Yeah. So, okay. Now we know more about these. So, Okay, so let's take a look at the horizontal distance then. What will happen? Right, so let's take a look at here. So we have these values, 24.999 to check, and the barrel cannot deliver items to a hopper, but then if it is 25.0, you have to include the 0.0 here, because if you just have 25 here, it actually spawns right here. That's not what we want. We want 0.0, which will spawn at here instead. So the barrel can actually give items to this hopper minecart. So what is the Z coordinate? So it's 25, right? So 25 plus 0.5, because we want to reconcile with the minecart case. And then we would deduct it by 25.0, so that's 0.5. Alright. Cool. However, if you have this case, 26.0, that's the test value for here, it cannot be received. So you can see it's actually quite a bit weird, because 26.0 minus 25.5, which is actually 0.5, it can receive in this direction, but it cannot receive in this direction. Instead, we need to reduce this value by slightly a bit. We need to have 25.999 as an example. Then we can have this barrel receive this. So this is actually a directional case in conclusion. So yeah, I'm not going to talk about the specific details of this, but then what you can be sure about is that as long as the minecart is the hopper minecart is halfway inside the barrel, then it would be able to suck items. So what would be a half block? One of the good ones is a wither skull. So hopper minecart, if we just place it here. So this barrel will give items to this hopper minecart, and let's check for the reversed case. So we also have this here, and then we have this hopper. It gets nudged. Okay, so yeah, again it would receive it. So why is that? Because when the minecart is halfway in, that doesn't mean that it's exactly 0.5 blocks in. It's actually in by slightly a bit more. So we can do the data get entity UUID POS. It's actually slightly less than 26.0 here in this case. So it will be the same in the other case actually. So yeah, 25.00999 something. So this essentially means that even though the entity is halfway in, it's actually a bit more than halfway in if you try to nudge the minecart to the halfway position. So yeah, that's basically it. So you don't have to remember which direction it cannot receive. As long as it is halfway in, if you use a wither skull as an example, then it will always be well received. So yeah, don't worry about that. So that is all of the interactions between containers or minecarts themselves. So let's take a look at some other niche things. So for example, we have two minecarts here. This is the repelling effect. They will repel with each other if their longer side is parallel. What is the longer side? You can see it from the visuals. So this here is the longer side, because this to this here is the shorter side. You can see that this entity, or the minecart, actually has this 0.98 block length, and the shorter side corresponds to the length, but then the longer side actually has this extra edge here. So this is the longer side, okay? And if you see that if they are if they are at the same direction, well, essentially they will always be the same direction, but then if they are in the same direction like this, then they will basically repel. But then if they are in this direction where the two lines that are parallel don't intersect each other, then they would not repel. Yeah, I think I did make a mistake. They're both parallel, but then the longer side. Oh, actually no, because of the longer side one. So, yeah. Actually, yeah, never mind. So anyways, so, okay. Probably explained that a bit vaguely, but yeah, you can tell the longer side will repel each other. So how do you make it such that the longer side is not facing the same direction? So a good way is to just have this, because if you nudge a minecart along a rail, then it will remember its direction. So yeah, basically that. But then if you have the other way around, like so, drop it, you can see that they actually repel with each other. So yeah, that's basically this property. Alright, so let's move on to the next one, is to check how minecarts, or basically any entities, interact with pressure plates. Now, it should be trivial that if the entity is literally coinciding with the pressure plate, then it should power the pressure plate, right? But then if the entity is slightly above the pressure plate, then how much above would the pressure plate no longer be powered? So that's the thing we're interested in. So here we have the check values. So we have 66.25 here. But then this pressure plate, you can see, is not turned on. But then if we have 66.249, just slightly lower, then you can see the pressure plate is being activated. So it can detect at most 0.25 blocks, so 0.25 not inclusive. And then for the horizontal distance, then we have this check value, 25.366 versus 25.365. So this is 25.366. It doesn't activate the pressure plate. But then if we have 25.365, then it would activate the pressure plates. Now you might think, why does this number make sense? Yeah, it's actually quite a bit complicated. Let me actually conclude the results first. Basically, a pressure plate has a square detection area of 0.6 blocks and can detect up to I read that wrong. A pressure plate has a square detection area of 0.75 blocks and it can detect up to 0.25 blocks above. So yeah, how do we calculate the value 0.75? 0.25 is trivial. How do we calculate 0.75? Alright, so now, recall that this minecart here is 0.98 blocks long. So we ask ourselves a question. What would its theoretical value be if the minecart is exactly 1 block long? So naturally, this means that we would move the minecart here by 0.01 block because of the 0.01 block gap between the minecart entity and another full block, right? So this means that we would have 25.366 or 25.365 plus 0.01. So we conclude, let's use 25.365. So we would have this value, 25.375. Okay. Now, alright, the next thing we need to notice is that, yeah. So what would be the value of the minecart if it is exactly at the center? The answer is 25.5. So 25.5 minus 25.375. We come to a conclusion 0.125. We need to move the minecart to this direction by at least 0.125 blocks. So this means that the gap between this pressure plate detection area and this block edge is 0.125. Okay, so we multiply by 2 because pressure plate is also a square, basically. So we get the value of 0.25, which means there are two gaps here, 0.125 plus 0.125. There are two gaps here. So the square detection area is 1 minus 0.25. So it is 0.75. That's how we get the 0.75. I hope this makes sense. So yeah, that's basically how we derive the pressure plate square detection area. It involves just a bit of math. So yeah. Anyway, so next we will see the property when will a rail clip down a minecart. The answer is halfway in. So remember that we used wither skulls before. Well, we will use them again. So if it's halfway into the block, so actually not this way. You see, this way this doesn't work. It's not actually halfway. It's like actually slightly halfway outside. So yeah. So I don't like it. Yep, there you go. So if it's halfway in, you can see it actually clips down. But then if we use a smaller hitbox, what will be another smaller hitbox? It will be a glass pane. So let's just check with a skull. 24.8, but then a pane is 24.863. So yeah. It's actually 0.0625. So yeah. But then yeah, it doesn't reflect there. But anyway, so we will just have a glass pane here now. So if we drop down, the rail doesn't clip down. So yeah. So if it's at least halfway in, then the rail will definitely clip down the minecarts. That's basically the property. Alright, so next we'll investigate in this detector rail. So it is quite trivial that the detector rail will power anything surrounding it, but then if it is a container minecart above the detector rail, then you can actually use a comparator to give a signal strength. So if we just place one item here, it would give an power of 1. But then if you place a lot of items, there you go. If we just make it full, then we have a 15 power. Take out one item, it will be 14. So yeah. Alright, so that's that explained. And then we are interested in seeing when will the detector rail power. So the position of the minecart, essentially. So again, we checked some height values. We are only interested in the maximum height because I think it's also quite trivial, the lowest height. It's just basically when the entity coincides with the rail, right? So yeah, we have 66.8, so it doesn't activate the detector rail. But then if we change the value to a slightly smaller y coordinates, then it would turn on the detector rail and the redstone lamp below it. So yeah, so it can detect up to 0.8 blocks above and 0.8 exclusive. So what about the horizontal length then? Now we have this check value, 25.291. So this is 25.291, it doesn't power, but then if we just make the Z coordinate slightly smaller, 25.29, then it will power the detector rail. So again, why does this value look very peculiar? It's exactly the same reason as to this pressure plate. So let's just explain it one more time. So we will take 25.29, okay. So again, what would be the theoretical value if the minecart is exactly 1 block long or wide? Then we should add 0.01 to it. So we get 25.3. And what would be the value of the minecart if it's exactly at the block center of this block? That's 25.5. So 25.5 minus 25.3, that would be 0.2. So the minecart has to be to this direction by 0.2 blocks in order to have this detector rail being powered. So this means that there is a gap of 0.2 blocks here between the minecart, between this block edge here and the detection area. Okay. So we multiply that by 2 because it's a square detection area. So that's 0.4. So 1 minus 0.4, that will be 0.6. So a 0.6 block square detection area. And it can detect at maximum to 0.8 blocks. 0.8 not inclusive, but 0.6 inclusive. So yeah, that's basically the detector rail thing. And congratulations, that's the first part done. The properties of entities and their interactions. So next part, I would go on to explain one important key aspect of entity placement, that is a float. So what is a float? An entity float refers to an entity in a position where one of its coordinates, at least, consists of a decimal and a small number. And this can be expressed as n plus epsilon, where epsilon is a small number. It can be positive or negative. So okay, we would use this command here again, data get entity, this UUID, and here. So we see it's 24.48, a couple of 9s, 0, 4, 6, 3, 2, 5, 7. So yeah, it's essentially 26.49 minus a very small number. I will have a calculator calculate it for me. So that is 9.5368 times 10 to the power of negative 9. So if a block is a meter, then this is in terms of nanometers. So yeah, pretty awesome. I think the value is. So yeah. And why are floats useful? They're useful because they exhibit special properties compared to ordinary entities. They also can serve as a workaround when we need entities to be inside immovable blocks. So it will be later introduced in the next section. But then, yeah. And also, floats are usually in respect to a full block. So you can see this here, this minecart, is actually in respect to this block here. So it's just slightly towards this block. It's slightly in this block in terms of z coordinates. But then most part is still remain in this block. So yeah. And floats can be made sideways, upwards, or downwards. I would introduce all three of them, although upwards I would introduce it slightly later. It's very related to the next section. Sideways is the most common one and the most trivial one. And downwards is a recent technology. So I will introduce it here. And since it's a recent technology, I'm sure most of you don't really know how you would construct downwards floats. So it'll be quite interesting to see, I hope. So let's get ourselves dirty in hands to see how we can make these sideways flows. So for a minecart, it's actually the simplest. So you get a furnace minecart. So we just place it here. Then we will have a piston. It can be either sticky or not sticky, and then we zero tick it. How will we zero tick it? Place a lever or a button on the side of it. Don't place it at the back. Place it on the side. This here also works. Top it also works. Yeah. Just like that. And then we will get the floats position. Now, let's compare it to a ordinary placed entity. You can see that this piston arm cannot support this entity, but it can support this entity. That's one of the major differences here. And also, if you break this block, the minecart will fall down. Although it's slightly into this block is unable to support this minecart. So yeah, a very special property here. So yeah, and then things get harder when we need to do with armor stands or boats. So let's just get on with it. Instead of a furnace minecart, now we need a regular minecart. It's a necessary condition. And then we need mobs as well. I will use chickens here. So it floats up minecarts, and actually we need to get a mob inside first. So place your rails, place a chicken, minecart going into here, and then that chicken, minecart here. We float it like we usually do. We start with minecart first. And then we remember that we are floating towards this direction, so we need to maintain the float here. So we would use another entity. We would use a boat, like so, and then we get ourselves another chicken. The chickens are used because in vanilla Minecraft, if you don't have the mobs here, they would have the repelling effect similar to that here. So by adding these mobs here, the repelling effect disappears. In some servers, you don't need to have these mobs, but in vanilla Minecraft, you do need them. So that's the way you do it. So this boat will now maintain the float position that this minecart has. Basically, it will remember the Z coordinates, so we can remove this. So say goodbye to our chicken, minecarts, and then we would have this armor stand here. So we just push it. This is a bit dangerous, so I'll just push it like this. And this armor stand will now have the float position. You can see 33.249999 and then small number. So it's basically 35.25 minus a very small number. So yeah. And the armor stand is now floating. You can see it here. So if we compare it to a not floating armor stand, you can see that cannot be supported by the piston arm. So yeah. And this is the same if we want to do a boat float. So let's just do it again, just to practice. You can also practice yourself in the work download in the description below. So yeah, we again have this chicken minecart here, we float it. And then we will have this boat here, chicken here. It also automatically gets in, so very nice. Very cooperative. So this boat will remember the float position, so we can say goodbye to our minecarts, and then we would introduce our boat here. Boat, push it in. Oh, actually for the boat here, we don't push it in yet. We place another chicken because you know the repelling effect. Push it in. Now the boat is floated. We can say goodbye to this and oh, sorry for that. We will remove the chicken, and then now we want to get rid of the other chicken here. So you want to use an axe, you don't want to use a sword because you can accidentally break the boat. So goodbye. Make sure to leave a block here, and then it will be floating. You can see the piston arm cannot support the boat. So yeah, it is floating. Alright, so next we will get on to downwards floats. Downwards floats are very interesting because they can perform things like this. It will be affected by the block downwards, and they will move along. This block is supporting the block, while also this entity is also inside the block, so very interesting indeed. So all of these three basically work essentially the same. Right? So let's get on to doing it. So how do we do it? All three are exactly the same, actually. Well, there is another option for you to do with this minecart. I will introduce it in the later section there, I think. So yeah. So we want to do 4 blocks down. We want to place the 5th block because we are going to place a path block here. So 1, 2, 3 for the 4th block, path block, okay? And then we would have, this time we don't need the chickens. We can just place 5 furnace minecarts. 5. Why 5? Well, remember that I said minecarts are 0.7 blocks tall. Well, yeah, it is, but then you can see that this minecart loses some y coordinates. It should be 62.6 375. But then it loses just a bit of y coordinates. And that is where the downward slope comes from. But then, since minecart is 0.7 blocks tall, we would need to make it to a multiple of 5, so we need 5 minecarts. So yeah, you can see the last minecart, it would have a floater position, 64.7375 minus a small number. Okay. So then we would have ourselves a boat. So yeah, you can also see the boat, the y value 65.4375 minus a very small number. So yeah, we also make sure to remove this piston first, because we will later drop it in. So place a fence here, minecart, drop that, and we get the position of the minecart. We can see is 66 minus a very small number. So we have achieved the downward slopes. Okay, very cool. But then we also need to notice how we would get back the blocks to there. So you want to push it 0 tick downwards or sideways. You do not want to push it upwards, because it will unfloat this minecart here. So downwards here. And this piston already can support the minecart, so we can already remove some entities right here. So we don't want to remove it all, just in case it fails. So yeah, you can see that this already works. So very cool. So let's practice ourselves a few more times with the armor stand and the boat. So yeah, so 1, 2, 3, 4. This will be our path block. Place the 5th block, path here. Remove all of these. Place 5 minecarts. 1, 2, 3, 4, 5. Remove this. Place a boat here, so that we don't have to nudge it afterwards. Then place a fence here. This time we would get ourselves an armor stand. Place it here. Push it. And then drop it there. Let's check. So, yep, floats the position, very nice. 0 tick this in. Now we can remove these. So yeah, that is a floated position. Very nice. So repeat ourselves one last time. 1, 2, 3, 4. 5th block. Place a path. Yeah. So we drop 5 minecarts in. 1, 2, 3, 4, 5. And then place a boat here. And this time we want to get a boat. So again, we will just use a fence, because we can. You just ride the boats this time. Place it downwards. Or drop it, I mean. Yeah. Okay. So, you know, just for safety. Yep, float it. Nice. So we push it upwards, like so. And then do this. Check. Very nice. And yeah, and that's all of the 3 downwards floats done. Nice. So yeah, that's basically the sideways and downwards floats. I will talk about upwards floats in the next section, which will be coming now. Next section will be hopper clipping. Now, what is hopper clipping? It refers to a minecart clip into a hopper. That's it. And hopper clipping is useful as we would clip some container minecarts for some dropper hopper circuits because they will require the minecarts for completing the circuit. So yeah, you can see that we are clipping, for example, chest minecarts. You can also replace it with hopper minecarts for some cases. So yeah, let's get on to the first clip. This is the ordinary clip. You can see there are no blocks here, and this hopper can actually place items into this hopper via this minecart. And the cool thing is that you can place some blocks but underneath it. So yeah, very cool. So how do we proceed with the ordinary clip then? So we would use slanted rails. Yeah, as an example. And then before we start to clip the minecart with this slanted rail, we will place a fence gate here, and then we will place the minecart and break this rail quickly. So like so. Okay. Then we will place ourselves soul sand right here. And then we push it upwards with a piston. Remove this. So yeah, now we see this delivers items to this hopper. So very nice. So that's the ordinary clip. But then sometimes we will have some restrictions, for example, a repeater here. So how do we do that then? So this also works, of course. But then we cannot use the ordinary clip now because the repeater hitbox will prevent this minecart from getting down from the slanted rail. So we need to use another setup. So this is the power rail clip. So obviously, when I say power rails, we need power rails. So we get ourselves a fence now. We temporarily remove this. Instead of slanting it towards this like this, we do this slant instead. Replace our repeater. So we would move it into a fence like this. Drop it. You can see that this minecart is clipped into this repeater and this hopper, so we just have to remove this block. And done. This can deliver items to here. Very nice. So that is the power rail clip. But then, what if there is an obsidian here? So that is slightly more annoying. And the power rail clip would not work because the obsidian would obstruct this from clipping downwards to the hopper. So we need to use another method. This is the reverse clip. So again, let's just see. This can deliver items to here. And the reverse clip is one of the biggest setups. So I might make a mistake here. So 3 rails like this. You can remove this one actually. Ordinary rail below this. And place a row of diagonally placed blocks. 1, 2, 3, 4, 5, 6, 7, 8. I think this should be enough. I'm not sure how much is enough. I don't really remember. If it's not enough, just add more. Easy. So, alright. We have the setup here done. Now next. This is customary, but we can use an anvil with a furnace minecart. The furnace minecart is the important part. The anvil is the customary part. So we place an anvil here, the furnace minecart here. So we walk towards this anvil to notch this furnace minecart downwards. We can remove the anvil afterwards. Okay, then we would send this minecart upwards, like so. So you can see this minecart is in this obsidian, in this repeater, and in this hopper. Nice. So what do we do afterwards? Well, we would use a flower pot. Flower pots can float by themselves, so we basically have to replace this rail quickly with a flower pot, like so. You can even remove the rail, this here. We can even remove this block. Flower pots can float by themselves. And then the nice thing about flower pot is that they will also break upon any block pushed into it. So we can just push it with a soul sand, like so. And then we will see this can give items to this hopper. So nice. We have completed the reverse clip. But then, what if we have so many obsidian like this, and we also want this minecart to be floated this way, such that this hopper can give items to this hopper? Obviously, this will also work. This will involve a couple of clips and floats. The downwards float, sideways float, and clip between these two obsidian. It can also be these two, but I will just show you these two. Okay. And quite frankly, it can also be these two, I think. Yeah, it can. So, anyways, let's get started. We will remove these. So, we said that we want a downwards float. Okay, so let's get on with it. We will float this block here. So, 1, 2, 3, 4. Place the 5th block, remove the spawn. Path block, place it here. Then I'll just use chest minecart because it's in my inventory. Chest. Oh, actually, do not use a path block here. There's a simpler solution. Remember that I said for minecarts there's another way that you can place it. Well, is to use lamps. So, let's do ourselves at a time. 1, 2, 3, 4, 5. And the 6th minecart will be, so we can just place the 6th minecart temporarily. This won't be the actual minecart. So you can see it's floated downwards. So very nice. Now we would need to place the minecart in between these two blocks, okay? So how do we do? We don't have to take away this block actually yet. We will take away the hopper afterwards. Place 3 rails. This here, make this a curved rail, okay? Then we would move this minecart into here. So the curved rail will actually clip the minecart in between these two blocks, but we have to remove the curved rail or the block below it fast enough because we need it to be inside these two blocks. Otherwise, if we let it just go, it will just be in this one block. So we would nudge it, remove it. Oh, that is too slow already. So yeah, it does require you some timings, so that's okay. Also, it requires you not to have too much momentum. Or alternatively, you can replace this with a farmland clip, which I'll introduce you later. But then I'll just use this one. Oh, yeah, I failed it quite a lot of times. But then, yeah, I guess besides removing this block, you also want to remove this block. Like so. So yeah, now it's clipped in between these two blocks. So very nice. Right. So we want a soul sand, or it's just something not exactly a full block that will push it upwards. Okay. Now we need to remove this hopper. Okay. Then we find ourselves fence. Our fence is 1.5 blocks in its hitbox. So we will now push this over. will fall into here. That's not what we want. Oh. Yeah, right, because this fence is... so, my mistake. So, let's do that again. I guess a better choice would be a fence gate. Don't worry, it isn't a big mistake, so we'll just do that over again. Is it inside 2 blocks? Yeah, it is. So, yeah. So we do this. Push it. Now you see the fence gate will actually support it. Alright? So at this position, we want to proceed with the floats already. So we want to proceed with the sideways float. If we want the sideways float. If you don't want the sideways float, it's actually fine. But then in this setup, we want it. So we just float it. And then we can actually already drop down this. And place our obsidian even. So this will be received and put into here. And then we can also remove the remaining minecarts. And have this, which will also be received and put into here. So yeah, very nice. So that is the complete downwards float half clip. It's a half clip, it's a float. So yeah. Now, although this combination of blocks is basically just all of the combinations that you have, there are also some situations where this wouldn't work. And it's namely if you have repeaters. So yeah. If you have repeater in this and this block, then this will never work. Never. Because you need to drop the minecart down to be floated. And the repeater has a hitbox that will prevent the float. So it would not work. Basically. So there will be another method which would use the vertically upwards floats. But then that would first require you mobs, which I don't want to introduce too much. I'm not really specialized in mobs, first of all, and I don't really encourage people to use mobs. But yeah, anyways, that's not the main point. But then another point is that for the upwards floats, you will need a lot of space here. Because we will need to use mobs. Mobs are basically our only way to get it. And the mob would always be in this block here, which will suffocate, of course. So we need to push it down further by a few blocks, and then we need a couple of minecarts upwards such that this can be well received. So that's not exactly what we want. So yeah, that's why I introduced only the downwards vertical floats method. The upwards vertical float method will be in one of the resources I will introduce to you later. So yeah, anyway, so speaking about vertically upwards floats, so here is the vertically upwards float. You can hear the piglin just making noise all over the place. So you can see this can be received here. So you also want to notice that this entity is positioned at 65.3 plus a very small number. Now, this is important because this is essentially what the criteria for vertically upwards floats. We want the decimal to be 0.3 and then plus a very small number. Recall that a minecart is 0.7 blocks tall, so 0.3 plus 0.7, 1 block tall, and then plus a small number. That small number creates the float, and you can already know, I think you already know the good things about float, but then I just probably will show it here, is that you can place blocks here. So even though this minecart is in these 2 blocks, you can still place blocks here. And since you can place blocks by hand, they're not counted into the volume. So this minecart here, although it's slightly in these 2 blocks, they are not counted. it doesn't constitute into the void. So upwards float is essential if you have a dropper hopper system that requires you to have this hopper at the top layer, because then you don't have to count these blocks into your final volume. So yeah, that's basically why this is important. It's for a very special case. Otherwise, you won't really use vertical float. So yeah, let's get started on doing this. I will introduce you this method only. The other method will be in the exercises, and you will discover it by yourself. So we place a daylight sensor. Daylight sensor is 0.375 blocks tall. And then we would place ourselves a mob here, and then we want this zombie piglin, a baby one. It needs to be a baby one. So we would have 3 rails here. How do you spawn as baby piglin? Just do no. I always fail the first time. So you want to place this and then click on the adult one. So that will give you a baby one automatically. So yeah, this baby piglin here, and then now we drop it onto the daylight sensor. And then now we will proceed on our actual floats, which will be the chest minecart, of course. So before we drop it down, we want to float it here. And you can also do another sideways float here if you want, but then it's not important here, so we just drop it down. So you can see you can deliver items like this. And it's also vertical floats. You can place blocks here. So very nice. So that is the vertical float, or upwards float. I always say vertical float. Yeah, upwards float. So yeah. Also, yeah, it isn't that important. But then in the documents that I have in the description below, I also have a link that I use the farmland trick to complete this downwards float half clip. So if you want to check that out, or just revisit the video without actually having to go to the timestamp of this video, you know, it might be a bit troublesome. So yeah, anyways, now we talk about a lot of clipping methods, but then there's also one thing I haven't really talked about, is that if we want some sideways clipping, but then there are obsidian here, for example, then what should we do? Well, we can do sideways floats, but then if it's actually clipped into the hopper, then we actually cannot float it in the ordinary fashion. So let's just see why this is. I'll use the power rail clip because it is simpler, in my opinion, and also easier to reset, and easier to establish as well. Fence, thank you. So we clip it first, move this, and then if we float like the ordinary way, watch what happens. Well, you need to move the block. You can see this minecart will be pulled substantially into this direction instead of floating into this direction, which is not what we want. So how do we fix this? Well, let's do the clip again first. So chest minecart clipped into here. Now the way we would fix this is to use a chest. So when we float it this time, it will work, and this hopper can deliver items into this hopper. So that would be the sideways float full clip. What happens if it's full clipped, basically. So that's all for the hopper clipping part. Now I'll just introduce you, or just revisit, some useful entity placing techniques. Some of them are revisit, some of them are probably new to you. So to get a minecart into an obsidian, one of the ways is to use a curved rail, which I already introduced you just now. So basically you have this curved rail right here, and then you can just push your furnace minecart here as an example, like this. It should be into this block. It's actually a bit into this block as well, so due to the force. So you can get it into the exact block by pushing it into it. So yeah. But then, what if it's not a minecart? Then we cannot really do that. And sometimes in some positions, you cannot use this clip as well. Then there is another way, actually, that is use the farmland clip. So let me just explain why the farmland clip works first. So either farmland or path block. I use a path block usually. Actually, in this demonstration, I need to use a farmland. So this before is a bug in 1.12.2 that if you make the farmland into dirt, then the player would get stuck into the dirt block. We're going to fix this by having entities to be teleported up to the next full block. And all entities, essentially. And hence, we have the farmland clip that will work. So, alright. So, a farmland or a path block is 0.9375 blocks tall. And in order to have the farmland trick work, we would need to have the entity to be higher than 0.9375 for the top tip parts. So, for a minecart, this would be using 3 snow layers. Because 3 snow layers is 0.25 blocks tall. Then we can just place a minecart here as an example. Go down like this. And yeah, 0.25 plus 0.7 equals 0.95. So 0.95 is greater than 0.9375, so the farmland trick would work. So yeah, we will just have this, and then we will place our path block like so, and then we would just zero tick it there, and then you can see this will be into this block here. Then we can push it back. Done. So this works for all entities. As long as the top part of the entity is above 0.9375, above the farmland or the path block, then it will work. So yeah. And then the last one, I think you've probably already seen it a lot of times. It's just block zero ticking. So just that. Then you can place movable blocks into entities without moving them. That's it. So these are all the techniques that I have to show you. Now I will get on to the special block properties. So yeah, let's get on to that. So you don't have much to see here, but then I'll just read it out from my documents. So for Sosan, Sosan is a very special block because it has internal height hitboxes at every 1/8 of a block. So 0.125, 0.25, 0.375, so on and so on and so on. And up to 0.875 because it is 0.875 blocks tall. And it is a solid block, actually. You can prove this by having this. And it can support any redstone components, so a repeater can be on it, and a pressure plate as well. So even though it's 0.875 blocks tall. So yeah, very interesting. And just a hint for you, in the exercises, some of the questions you would also encounter with the use of Sosan. Right. So let's go on with the next few blocks that you'll probably also use. For example, a fence. It is 1.5 blocks tall, and it has a 0.375 block gap from another adjacent 4 blocks. So how do we prove this? Well, height, simple enough. If we walk to here, or walk to a full block, 23.7, okay. If we walk to here, so we have 23.7, and then 24.075 minus this. So this is 0.375. So yeah, 0.375 gap. Yeah. And slightly differently for a cobble wall, it's also 1.5 blocks tall. You can see it from the y coordinates. And then if we walk towards the cobble wall, and instead of 23.7 or the value 24.075, we have 23.95. So 23.95 minus 23.7, that is 0.25 blocks. So it has this 0.25 block gap. So yeah. So fences and cobble wall, usually you would use fences, but then in some situations where the horizontal manipulation requires, then you would use a cobble wall. And there are also some other ones. For example, chests and honey block, they have the block gap 0.0625 block. So yeah, basically you can see it's 23.7, and then if you plus 0.0625, you can see it's 23.762, but then it's 23.7625. Let me see if I can get myself. Yeah. It is a bit in the float position though. So yeah, don't worry. That's fine. Okay. And then next we would have composter. So composter has internal height hitboxes at every 1/8 of a block. So 0.125, 0.25, so like a soap sand. But it also has a full block. And if you sit into a composter, as an example, is 0.125. So yeah. It also probably has horizontal internal hitboxes, but then I cannot be sure where it is positioned exactly. So I'm not going to tell you false information. So yeah. For cauldrons, the internal hitboxes are 0.1875, 0.25, 0.5, and 0.75. And if you sit into a composter, a cauldron is 0.25. How do you prove this? You will prove this by command blocks. You basically temporarily remove the composter and allow this minecart, as an example, to fall. And then you just take the data of the minecarts, and then until it falls out of the composter or cauldron. So you can always prove it like this. So yeah. And then for repeaters and comparators, they are 0.125 blocks tall. Simple enough. And for a trapdoor is 0.1875. And obviously for trapdoors you would have multiple place orientations, of course. So you can have a top trapdoor like this, and then you can also have a sideways trapdoor like this. But then you will automatically know how the hitboxes are positioned. So yeah, it should be quite trivial. So as long as you remember it's 0.1875 blocks tall, that's good already. So yeah, that's basically all of the hitboxes or special blocks that I will introduce to you. They are special blocks because they are used quite often when you are coming across to placing entities. So yeah, these are the more common ones. There are also less common ones that you might also need to use in the exercises, but then I'll just let you dig up yourselves. And yeah, and the list of all the internal hitboxes and entity sizes can be found in the document Entity Sizes and Block Sizes 1.19 by Rayworks. This is the entire document name. I'm not sure if all the data are dig by Rayworks himself, but then yeah, just check in the link in the document and you will find it. So yeah, it's quite a useful document when we are messing around with entities. It's very to the advantage for our reference. So yeah, after the special block properties, let's get on to some basic entity circuits, and which a lot of other Redstoneers have already developed. So just take the circuits from them. So the very original one, this is called a Wilux double bit extender. It's developed by Wilux. So it's basically a flush and seamless downwards pressure plate double bit extender. So yeah, how would you build it? It's actually quite simple. You would have a slanted rail here. This is how I would build it, but then you don't have to build it exactly like this, but it's just my method. Then you have this. Also, if you're pushing blocks downwards, then you don't actually need zero tick. Like so. Pressure plate, this here, and then finally the lever. Cool. The next one would be a flush and seamless sideways pressure plate double physics extender. Instead of a minecart, now we use an armor stand. We will have a block that supports it. You can also use a minecart actually, but then you will need to support it at these positions, for example. So let's build it. Just build this first. Then pressure plate. Yeah, you can also use it with a skull. I'll introduce that with the skull later, but then I don't encourage you to use it, because removing it is actually quite problematic in vanilla Minecraft. So you have this here, just retract this. You can see it does the auto retraction. So yeah, all of these pressure plate stuff are just for auto retraction. So yeah, it's quite nice. So yeah, you can see the pressure plates basically will automatically power the front one. So yeah. And the next one would be an upwards one. This is actually quite redundant, but then it just basically shows that you can have entities like this, and then it will still work for the upwards one. Now this is clipped into the piston, although you will see in later designs that it would be floated instead. So they have some different properties, but I will just let you play it with yourselves. So yeah, anyways, so let's get on with this. So how I will build it is to have this here, 2 rails, this here. Since there is a fence there already, we can just push it like this. Don't remove this block. Yeah. I want to block this because I know I will break things. And then you would have another fence, but this time at here. So place it like this here, and then this here. Like so, this here. Lastly, place your server and your pressure plates, and you will be all good. Place your lever. You need this minecart to block this minecart from being pulled up too far. So yeah, that's basically it. So these are the double piston extenders. They're quite simple. They're all flush and seamless, so very nice. So next we will talk about some triple piston extenders, which some of them are not flush and seamless, but then they are still good designs for us to refer to. The first one is the downwards one, is also by Wilux. So we would use a button input here. Notice that all of these are using a lever inputs. Because button inputs, quite frankly, you already know all of them, so I don't even need to explain it to you here. But then for the lever ones, then you would naturally think, how do we even do the retraction? But then, yeah, pressure plates would help a lot. So yeah, that's why I introduced the lever ones too. But then for the triple extenders, then we do need buttons. Buttons are quite necessary. So yeah. For this one, how would you build it? Again, very simple. We remove the top one, clip this in, furnace minecart down here, no block, put down so, this, push it. Do this, no. Then lastly, place your button here. Very nice. So the next two are pushing triple piston extenders. So this is a trivial one, this is also a trivial one. Now, as competitive redstoners, we will prefer this design more because it is 3 blocks tall instead of 4, so it will usually be layout sized. Well, it will be layout sized for this one, and not for this one, so we don't really like this one. and the 3 observers are quite necessary is for the delay. So yeah, you can obviously just expand this a bit such that you would have this instead, but then yeah, the purest form is this one. So let's just see how you build it. Yeah, it's quite simple again. I think you would probably very fluent after building all of these because they're literally exactly the same. Come on. I can't place it. Thank you. So yeah. So that's that done, and then for this one, again we find ourselves this here. I'll place an observer here this time, so I don't have to replace it every single time. Observer here. Downwards, replace this. This here. And this time we need a dropper. Now the pressure plate will power the dropper. I think that's pretty trivial. But then if you don't want to use a dropper, you can use a hopper and a dust on top. So that also works. So yeah. And this here. Done. And the next two are observerless. You can see these are pushing ones. So we want to have some ones that are either splitting the block or just extend the block. So these are observerless design. This is by Nacay and Queen 957, and this is purely by Nacay. So they both use burnouts because burnouts are useful in observerless ones. So this one, this is a splitting one. This is a constantly extending one. So yeah. Let's just see how you build it. I think it's quite trivial from the outside as well. So sticky piston here, and then to build it fast, 2 rails. This here, remove this, and then no block here. I don't like the no block sound. I'll just use a structure void to silence it, so you no longer have to annoy me. So we will need a dust torch. Place your dust torch. Good. So now we do this. That will work. We will do this another one while this resets. So, good. Then the next one is again very simple. 2 rails. Here, break this, and then now we just place the remaining ones. This dust here, this is a free tick, this is a torch. So yeah, there you go. So these are the downwards one completed. Now I will go on to the sideways one. This is by Bruhjef. And it uses wither skulls. They are legit because if you're proven that you can build this in survival, then it's legit. So yeah, let's just show you how this works. The working principle is actually quite similar to this here. So yeah, nothing too special. So yeah, although I won't be using a wither skull because I don't want to clear it afterwards. There are some commands that you can use to clear it, but then I don't really like to do that. The commands are also linked in the documents. They are also placed in the documents, so you just refer to it. But then here I'll just use an armor stand because it's simpler. Again, you can also use other entities like Minecarts, but then you also need to support it by something else. So I'll just use an armor stand because it's easier. This here. Then you want pressure plate. And you're done. So yeah, and the next one is this. It's actually, I think, quite similar to another one. Actually, no, never mind. Yeah, anyway, so this one is a splitting one. Now, I guess it's also worth it to tell you that for the double extenders, you can just give one pulse, and then this pressure plate, you can just change it. For the triple ones, you cannot. The pressure plate it uses is really dependent, and also the buttons, actually. So this uses a stone button, this is a wooden button, do not change it. Same here, wooden button, but then this one uses a stone button, so again, do not change it. So let's just see how we will build this. So we have 2 blocks here. Armor stand. I don't know why I have to remove this, but whatever. Place this here. Temporarily remove this block because it will just power stuff. Place a button here. Block the observers like this. Then you would have pressure plate, and then an observer here. This, and you're done. So this button, stone button, is for this piston to retract it after the one ticking. Yeah, you can see that here. And the pressure plate is for the pulse length. It needs to delay for the stone button, basically. So yeah, that's for the sideways one. We will go on to the upwards one now. So this is by Mingyu 787. So I'll just give you a Bruhjef. Yeah. So yeah, this uses quite a lot of entities. This is necessary for me to show you. So the working principle again is quite similar to these two. So they just repeat it over and over. So yeah. It's quite funny how they basically have different creators. But anyways, so we will just build it. Button input, wooden button, and now let me just check. It is 61.375. So what would be a good choice for 375? It is a daylight sensor, but then daylight sensors are immovable, I think. So I would use C pickle. Specifically C pickle, I think. Oops. Yeah, C pickle 2 works. I don't know if C pickle 1 is. Oh, C pickle 1 also works. Yeah. Anyways, that's not the important thing. So we would have rail. Furnace minecart, don't remove the block because we need to float it. This time we need to float it. Like so. Drop it down. And then the C pickle will support it. And then later we can use the soul sand to do this, and then it will be placed there. Then next we need a fence. Place it here, here. So take it downwards. Actually, before you do that, we want to place a minecart here first. Now you zero tick it, and then oh, actually this furnace minecart doesn't have to be floated. The one that has to be floated is this top one. Sorry for my mistake, but then I mean floating it doesn't really hurt, so don't remove, please. Thank you. Float it. Push it, drop it down. Fence here. Then place its plate. And why do we need a fence? That's because to support the minecart above here, like so. And then we have this here, and then we place 2 dusts, like so. And finally, we are done. So yeah, the bottom minecart doesn't have to be floated. The one in the middle has to be. So yeah, that is for this not flush one. So we need a flush and seamless one. So this is by RedXD. So it's quite compact. It also works quite funny. So let's get on to building it. So let's build the trivial parts first. Then this, obsidian here. On, there you go. Good. And now we will place our furnace minecart. So if you recall, our cauldron is 0.25 for the internal hitbox. So 0.1875, but then that's not high enough. The minecart will eventually go back to 0.25. 0.25. So yeah. And okay, so float it, drop it down, cauldron, take a second. This, done. Next, we need to have something that will block this here. Which, now we'll place a repeater here first. This rail again. And this time we'll use a chest because chests and honey blocks, they're useful when you want to place entities that you do not want to activate the pressure plates. So, yeah. So place it down here, and then you have the soul sand. So you take it, and then yeah, that's basically done. So place the remaining blocks. Remove this. Cool. So that's that done. Oh, and I removed this. Yeah, whatever. So anyway, so that is those extenders done. Now we'll go on to the transmission circuits. Okay. So here we have this signal. No, here we have this tripwire transmission. There is no string here actually, just only this here, this string, this here. Only one string and two tripwires. You can extend this tripwire all the way back there, up to 40 blocks for this thing. But then this has a limitation, which is that it's directional, because it only works in the north and east direction. The south and west directions do not work. So yeah, it's directional, and it's not north-south and east-west pair, it's north-east and south-west paired. So yeah, quite a bit special. So it has its limitations, but then if you can use it in some situations, then yeah, I'm sure you'll find a use for it. It's also used in some doors actually. So yeah, and then we have the next thing that will be cobweb timers. Cobweb timers are also very important, and it basically involves entities. Cobweb timers are used for two distant pulses. You want one pulse and then have a long delay, and then you have another pulse, two distant pulses. So yeah, and sometimes hopper ROMs are just too large for you. Yeah, and burnouts as well maybe. Well, some burnouts are a bit faster, and sometimes that frequency is not able to comply with some needs. So cobweb timers remain very useful, and it's also relatively small as well. So you can see this here, after quite a long time after this mica falls, and this here. So yeah, there's a couple of variations. This uses a string. If it's pulling upwards, then you want to use a pressure plate instead, because using a string, then it will actually get reactivated quite fast, because string does have a larger detection area in terms of its height. So you will want to use a pressure plate instead. So yeah, and then for this here, you can also see this is in fact inside the piston, and it also works. Now, I want you to notice one thing, is that this actually works on retraction here, not extension. So yeah, that's basically the important point for you to realize. So yeah, that's basically all the cobweb timers. Of course, you can replace the minecarts with other entities as well. It doesn't really matter. So yeah, just be creative yourself. And yeah, next thing, I will talk about some transmissions, which is, for example, downwards transmission. You can use a cauldron with a minecart, and then a detector rail like so. So yeah, and remember that you do not want the minecart to be halfway into the detector rail, so just be careful. So yeah, and the next one would be to have horizontal transmission with pressure plates and composters. So I have these setups here, but then the actual setup is only involves this piston, this composter, and this pressure plate. The reason I have this setup here is because if you place the entity, you can replace these minecarts with any entities you like. Sometimes we use boats. But yeah, anyways, so if you place this entity further or closer to the piston, then different effects will happen. So if we just flick the lever, slow it down, you can see this extends first, then this extends. So yeah, we can see it slower, and you can see this extends, and these two will extend at the same time. And if we place a lever here, which will be player input, so this repeater will be 1 game tick faster, then you can see these two extend at the same time, and then this one. So we can conclude that the difference between these two during extension is 1 game tick. And most importantly, I find this very interesting, if you have a stone button here, this will retract first before this one. And for wooden button, it actually has the same story. And this here, if you use a wooden pressure plate, the same story for a stone button, but then for a wooden button, you can see this turns off 1 game tick earlier than this one. So yeah, I think that's just an interesting thing for you to notice. So yeah, just basically telling you that placing it here and here have different outcomes. Also, you have to remember that first, pressure plates turn off on a frequency. Basically, it will check every 10 or 20 game ticks to see if it can turn off. So yeah, I probably explained that in previous videos. So yeah. Anyways, so we would move on to the last things, which are zero-tick circuits. Actually, I'm not going to tell you how to build it. You can find in the links down in the description or in the documents. So zero-tickers find sand falling instantaneously by boats very useful, because we can reset circuits very fast. So originally you have sand that normally falls at a normal speed, or you will have observers, which will imply reset time. But then having boats like this, the sand would be teleported to its original position basically immediately. It's the same for this setup here. So yeah, that's why we will place boats here. Boats can help the sand to be teleported down basically instantaneously. So less reset time and more compact zero-tick circuits. So yeah, check the link in the description below if you want to know how to build it. Both videos are by Alugia, a clever zero-tick redstoner. So yeah. So that's for all of the circuits already. So congratulations, we have been through all of these circuits and stuff in nearly 2 hours. So before I go on to the exercises, I want to talk about some useful resources. So you've probably heard me mention quite a bit before in some sections. So for the first resource, I have the documents, entity sizes, and block sizes 1.19 by Rayworks. So the link will be in the documents that I will provide you in the description. So just check that out. And the second resource will be the video and introduction to placing minecarts in hoppers and other immovable blocks by Armadillo28. He is a very He's an expert in placing minecarts, entities, and mobs, essentially, and makes some very clever builds using entities and mobs. So he has made a video just to explain some ways to place minecarts and entities. And although some of the methods mentioned there are already a bit outdated, they still work, but then they are not as efficient as current methods that I've introduced in the past video. But then some of them are still very useful, especially the upwards vertical float one for the setup that can replace this here. This hypothetical situation which you usually don't need. So yeah, the upwards float method, it's still very useful, so you can check that out if you want to. And hopefully you'll also learn some more placements, because he also introduced other placements for hopper clips, which I didn't really introduce much here, because I'll just let you figure it out by watching his video. And the third one will be some changes in hopper internal height hitboxes, because before 1.18, hopper internal hitboxes are every 1/8 of a block plus a special one, 0.6875, so that's 11/16. And yeah, after 1.18, Mojang decided to reduce a lot of the internal hitboxes for hopper, maybe for game performance issues. But yeah, anyways, they just reduced a lot of internal hitboxes, and then now you just have 3 or 4 values for downwards or sideways hopper. So you can just refer it in the documents below. And the fourth one would be the reusable command list. So you already see me using some of the commands. For example, the data gets entity UUID position. That one is quite useful. And if you want to test out some minecart placements in which how they would behave here, for example, you can see me using /summon minecarts, and then you plug in the values XYZ, and then no gravity tag 1. So yeah, and then the third and fourth one are regarding wither skulls. So yeah, just check that out, and hopefully you don't have to use them because they're actually quite a mess to play around with. So yeah, that's all of the resources that I'll introduce to you. So now I'll go on to the exercises. So the exercise this time, so we have these two that requires you to build piston doors or staircases. So for this one, you can actually have this piston being exposed during the extension. It's completely fine, just saying. This one will be to introduce you another way of doing vertical float. It's a more traditional way than the new way of using baby zombie piglin. But then baby zombie piglin is a bit more compact, so I'll introduce that in the video and leave this one to you as an exercise. So this one is to ask you to use the command to find the y coordinates in terms of n plus epsilon. So yeah, and then using this result to do the upwards float. So remember what I've said in the video, what criteria, what conditions are needed for a vertical float, and you can complete this question with ease. The third question is a challenging question. It's just basically to, when this lever is turned on, you would need to make this piston be able to control this redstone lamp turning on, and this off, this has to be off. Constantly on, constantly off. So yeah, that may be a challenge, because you will need to basically use some entities, and then that entity might get pulled too far into this position during the retraction, so you will need to find some blocks that will block it. So that will be my hint for you. The fourth one is basically an observerless method of powering these for pistons. You don't have to use observers in this question, although I don't restrict you, but then it won't work, basically, because I asked you to constantly power the pistons. So yeah, you would basically need to use entities. So yeah, think about what methods you can use to power these. And the fifth one is just piston door making. You might find some auto retraction stuff useful, and perhaps maybe soul sand would be useful in some of these questions, so especially this one and that one, I guess. And the sixth one, the final one, would be to ask you to make a double floated boat like this, so inside these 4 obsidian, because I thought why not make it as a challenge for you. So yeah, you can find some methods that I've introduced in the video for you to do this double floats. Floats I've already explained in this section, and then how to make it into the obsidian wall. You have these methods so you can see which method works best for you and which method works or not, let's just say. And also these soul sand are here placed for you to check if they are actually floated, because if they are actually inside the soul sand, then the boat cannot even push up, basically. So yeah, good luck with the exercises, and I know that placing entities might be still very new and perhaps maybe quite confusing. So for this video, the exercise solutions will be in the form of a video, so you can always check that out if you need to, just to see how you can place the entities. And also I will explain the piston door concepts, so why you need some positions, or how you can think of circuits, basically. So why you need entities in some positions, or why you need to build a circuit like this. So yeah, these concepts will also be introduced in the solution. So I hope the video will help you on understanding more about these exercises. So yeah, thank you for watching this very long video. I hope you learned something more, and especially about entities and how you will place them, and maybe enhance your redstone building by learning more entity skills such that you can compact them. So yeah, good luck on redstone building, I guess, and thank you for watching. I'll see you in the next one.